All righty, cool. So the next thing we'll cover is how to actually add super elevation transitions to these lanes. There are a few different methods. So first one I'll talk about is calculating. I use this as a first pass at super elevation. This won't usually be like the end all be all of how I want to add super elevations points to my super elevation sections. But it is sometimes a good starting place. In the CDOT workspace, we do have CAD standards related to super elevation design coming from AASHTO. If you need to navigate to find new rules files, you can try to navigate there with that three dot button over on the edge there. For right now, we're just going to use the AASHTO 2018 XML. If anything new comes up, we can change the you can change that here. That XML will let you choose from these drop downs what your Emax is, what speed, whether you're using the speed table versus relative gradient, and your design speed, and your pivot method, whether it's crown, inside edge, whatever it is. For right now, we're going to use crown, and we're going to be just applying these using 60-mile design speed. This is all just based on AASHTO requirements. So what I'll do here is I'm going to locate my first super elevation section. Again, this is just that super elevation section that we care about. I'm focusing on this curve because this is the curve in this alignment that is actually going to have super elevation applied to it. There are a couple others throughout here that, sorry, just there are a couple others throughout here where we would get to like a reverse crown rather than just normal crown. But I'd like to focus on sort of the most severe angle here to talk about what these super elevations are going to look like. So I'm going to just click on my super elevation section. Maybe, there we go. I'm going to reset to complete. And now just, again, click through all of these commands to apply everything. And because I said open the editor, it's opening the editor. And boy, howdy. When I did this before, I didn't have the shoulders in here. So I believe that these are the shoulder super transitions happening here. That's kind of what's going on with a couple of these. You know what? Give me just a moment. I'm going to undo that because I don't like the way that looks. So I'm going to unapply those. I'm going to get rid of these shoulder sections. I think they might be messing a little bit with what's going on here. And then try doing that calculation again. So I'm going to do the same thing that I just said. There we go. That looks like a much better super elevation table. I like this a lot more. So you can see that it's populated a bunch of points here in the super elevation diagrams. So down here, it's applied some points down at the sort of beginning of the alignment. This is a very shallow curve. It doesn't actually require us to go to any sort of reverse crown or super elevation or anything like that. That's these points down here. These points over here, this is going to be that curve that I mentioned right here. This sort of group of points here, this is a slightly shallower curve than the one previous, but still enough that it's going to require us to have a normal crown. And everything here are these shallow curves further on that don't need a normal crown, don't need a reverse crown. They're fine with just a normal crown through those curves. So that calculation, that super elevation by calculation, is going to calculate all of these points, no matter whether you need them or not. as you can see, kind of in the case of these normal crown align or normal crown curves here. It's still looking at them, evaluating whether or not it needs the super elevation in them, and applying them. Here you can see it's taking, this is our tightest curve here. It's looking at the design and saying, hey, based on AASHTO requirements, I need a 3% super elevation here, and changing the lane slopes to accommodate that 3% transition at the speed that we've specified. You can also see visually here, there is a color transition between the 2% sloping up from the left to the right, and then the 3% sloping down from the left to the right. As if we were to change the super elevation of these to something more severe, let's say, so for this point here, I want to change from a 3% to, we'll say, a 6%. I'm just going to manually edit it in this cross slope here. You can see that that 6% now is a different shade. These, the sort of the hues go from a deep red to a deep blue. Blue is going to be a lot, it's going to be sloping up more to the, from low side left to high side right. And then the opposite is true for red, high side left to low side right. You can use this table editor to change any of your super elevations. A lot of these have some constraints placed on them. So for example, in using that super elevation calculator, it automatically applies a lot of these. So you can see here for this point, this is a point on the right side here. There is, sorry, just looking for the right point here. This one. So these points here are saying that there are two, so the red points here have two constraints on them. One is a distance offset. So it's saying that I know that I need a transition distance from this point up here. And it's also saying that I want to mirror the cross slope of whatever is up top here. So it's looking for the mirror cross slope here. You can use these constraints, or if you find it easier to just manually control any super elevation point that you're putting into your super elevation designer, you don't need to use those. What I'm going to do now is talk about adding points, adding super elevation points manually to these. So what I'm going to do here is I'm just going to insert a station cross slope. So what I'm going to do here is I'm just going to say, I know that, you know, for whatever reason in my design, I need to dip this section of the roadway from 3% to 2%. I can add in super elevation points to whatever lane I want. I can select my outside lane, inside lane. If I had my shoulders, I could select my shoulders. One thing to note here is this pivot about edge is a little bit counterintuitive. When you want to control a super elevation lane that is on the left side of your center line alignment, you're actually going to pivot about the right edge of that lane. And then same for the right side. If you're controlling a lane on the right side, you're going to pivot about the left edge. Again, it's a little bit counterintuitive. We'll get into this a little bit more with the importing super elevation as well. Like I said, I'm just going to add a couple of super elevation points here. So distance constraint, I don't need to add any constraints or anything like this right now. I'm just manually putting everything in. I'm going to pivot about my right edge since I care about a lane on my left side. I'm going to choose transition type linear. We'll get into the different transition types a little bit later as well. And I'm just going to say it's an undefined type. You can choose full super, normal. You can choose reverse crown if you want to. If you are kind of just editing through, it's not as necessary. So I'm going to choose this superelevation lane. You can see it automatically populates a station in here. The beginning station of this alignment is 100 plus 00. But I'm actually going to graphically choose a location here, so I'm not going to click this. If you know exactly what station you want to use, you can click this and type that in. But I'm just going to choose it graphically. Now I'm going to click through until it asks me where I want to do it. And so you can see that as I move along my alignment, it's allowing me to graphically choose this. So I'm going to start here. And I know that I want to start at a -2%. So I now have, when I go to select this, you can see here, there is a super elevation point that has now been generated at this point. If we go up to the curves as well, these are the ones that were automatically generated by that super elevation calculation process that I went through. The arrows sort of help indicate which way it's sloping and the magnitude. You can see like 2% has a nice little skinny arrow, 3% has a nice fat arrow. A level slope has arrows pointing at each other. This is just a good way of kind of visually checking like, okay, is my super elevation transition actually doing what I want it to do? I'll add a couple more points just as examples here. So I'm going to add another one here. And I know this time I want to transition to, I'm going to say a -4%. You know, maybe I need to dip down to match a cross slope that's coming in, or crossing road that's coming in, or something like that. So I'll go ahead and do that. Right edge, I'm going to transition it up to here. This one will be 4%, again, undefined. And you can see now, these are the 2 points that I have here, 2% transitioning to 4%. And then as it transitions back to here, this is that coming back up to the 2%. You can manually add these points as much as you want. It's a little bit tedious, but it is a good way to, like, if you have a very fine control that you need to include, I find it a helpful tool. You can also utilize this super elevation editor to add points. So I'll go back to the super elevation editor here. And you can see here, there's an add new. And it'll ask you to select your super elevation. You know, in this case, I was editing that lane L2. So I'm going to add that, and it'll bring up this same dialog box. I'll just edit out or exit out. But yeah, that kind of covers adding super elevation points to a super elevation lane or a set of super elevation lanes. Let me just check real quick. I think that is that's editing super elevations. I think that's a good place to stop for right now, and we can take some questions about that.